So we're going to start off today by continuing our discussion of factory method operators that are in the Flux class. We've talked about a bunch of them so far. We're going to talk about yet another one called generate, and this is used to create an infinite flux stream. And let's talk about how and why this works. So the generate operator creates a flux by generating signals one by one using a callback that's passed in here as a parameter. This parameter is a consumer parameter, and it's called in a loop after a downstream subscriber has subscribed to this flux stream, thereby setting the wheels in motion, as it were. The callback is going to be using something called a synchronous sync to emit signals. And it'll do this by calling the next, error, or complete methods on the synchronous sync in order to indicate the values that need to be propagated. As usual, next actually gives the data, and then error and complete are used to indicate whether things have gone wrong or the stream is just done. A new Flux instance is returned that will emit all the events from the generator, and this will go on infinitely unless you limit it using the take operator or some other suppressing operator. And I had fun with ChatGPT generating me something like this, which looked pretty cool. What's returned by the generate operator is a so-called cold flux. What is a cold flux? A cold flux is a type of flux that only emits items when some subscriber has subscribed to the publisher, to this factor method. And you can take a look here for more discussions about hot versus cold publishers. A hot publisher will emit events when it starts and doesn't really care if anything is connected to it. Think of it like a radio signal broadcast, which will broadcast irrespective of whether there's anybody listening or not. Each observer, each subscriber, therefore has its own set of items emitted to it. So when you subscribe, you become the recipient of the items that are going to be generated by the generate operator, and each one gets its own precious set of values. Now, what's interesting about generate is it only generates one event at a time, which does sort of support back pressure, kind of, in a very limited way, because it's one at a time. So what this will do is it'll generate an infinite stream of random unreduced big fraction objects. You can see here that we say sync.next, because that's the synchronous sync, that's the parameter here. And we're going to generate a random big fraction that's not reduced. And that'll just go on forever. We never stop doing that. Therefore, we need to limit the amount, if we don't want this to go on forever, by using a suppressing operator like take, which we've talked about before. So this will limit the number of random big fractions up to S max fractions of them. In contrast, the one parameter create operator, which we've talked about earlier, I think that was one of the later, most recent factor method operators we talked about, will produce events whenever it feels like. So it wants it in the way it wants it, and that's just tough luck if you don't want to handle all those events coming at you as quickly as possible. In other words, the one param create operator produces events when it wants to by ignoring back pressure. There's no back pressure, whereas the generate method will generate them one at a time, giving a chance for it to be processed before the next one is generated. RxJava, as usual, has a generate operator that works in essentially the same way. This is just the way you do it with observable. And Java Streams has a generate operator that also works in very much the same way. So stream.generate, in this case, will generate a stream of random large and unreduced big fractions. And as usual, it would behoove you to use the limit operation provided by Java Streams if you don't want this thing to go on generating random big fractions forever. So generate, it's a useful factor method to be aware of. I haven't found a lot of use for it in my work except for generating events for test cases. And we'll take a look at that when we get a little further along. We're looking at the case study EX3 that corresponds to the various operators that we're talking about in this particular part of the lesson, this particular part of the course. So that's the end of the next factory method operator, and this might be the very last one we talk about. So we've talked about around a half dozen or so factory method operators in Project Reactor's Flux class.